everyone. This is NetMaven. This is a new series about Cisco Nexus VXLAN EVPN hands-on lab in Nexus Dashboard 4.1. We will walk you through Cisco Nexus VXLAN EVPN and focus specifically on using Nexus Dashboard as management and control platform. The goal is to show how a modern data center fabric is built, managed, and validated using best practices instead of the manual switch by switch configuration. This is part of Cisco Cloud and AI infrastructure portfolio, and it reflects how VXLAN EVPN is deployed in real enterprise environment today. This lab follows a clear end-to-end flow. We start with an introduction and a basic installation concept, and then move into fabric creation using Nexus Dashboard. After that, we configure interfaces via apps and networks, then attach those networks to real switch ports. Once the internal fabric is working, we configure external routing so traffic can leave the VXLAN fabric. Finally, we verify the configuration and review operational tips inside Nexus dashboard. This mirrors how a production fabric is normally deployed and validated. We will begin hands-on configuration by logging into Nexus Dashboard. Nexus Dashboard acts as a single console plane where fabric, switches, policies, telemetry all come together. Instead of logging into each Nexus switch individually, almost everything is driven centrally from this interface. This lab uses a full VXLAN EVPN topology with the spine switches, multiple leaf switches, and a border connecting to an external router. The fabric includes VPC pairs, server connections, and multiple tenants. Each tenant has its own VNF, VNIs, VLANs, and IP subnets. The environment also includes an external fabric and a WAN router to demonstrate north-south routing using L3 out. So all switches are managed by a single Nexus dashboard node using the management interface. After logging in, we will land on the Nexus dashboard overview page. It's a central landing screen where you can see high-level system status. From here, all operations are performed either from the top navigation bar or the menu on the left. This single interface replaces the need to manage each switch independently. The top bar is used for quick actions and system-wide visibility. From here, you can search across the fabric using IP addresses, MAC addresses, or interfaces. You can also access system information such as software version, help documentation, and links to Cisco resources. Critical events and alerts are surfaced here, along with user settings like password management. You can all get them down in this top bar. The left menu is where most of day-to-day operations happen. This home section provides dashboards, topology views, fabric-wise visualization. The manage section is where you register switches, create fabrics, and then manage policies. The analyze section focuses on analytics, anomaly detection, um, alerts, traffic, visibility. The admin section handles Nexus Dashboard system administration tasks such as backup, logs, and user accounts. Although Nexus Dashboard handles most configuration, it is still possible to access individual switch using NX-OS CLI. In this lab, we're going to access the spine and the leaf switches through console using multi-party, and we're logging with the same admin credentials. We recommend is how you understand out-of-band management synchronization before you make any CLI changes, right? Because manual CLI changes may be overwritten by Nexus dashboard policies. Nexus OS NX-OS allows show commands and the basic test commands like ping to execute even were in configuration mode, right? Commands such as show version, show module, and show running config can run directly without switching modes. The CLI parser also supports tab completion and context aware help, which make interactive troubleshooting easier, like you see here. NX-OS uses feature-based model. It means many functions such as interface VLANs or VXLAN overlay are disabled by default and must be explicitly enabled using the feature command. Another key difference is that interfaces are unified under Ethernet interface type, and ranges can be configured easily. So this is the design very similar to traditional iOS, which makes adaptation straightforward. Now let's talk about some initial setup requirements for Nexus switches. You are seeing 9300, 9500 Nexus switches. The Nexus dashboard communicates with switches through management interface, management 0, right? Um, so each switch must have a management IP address configured. In this step, so those settings are already completed. Power on auto provisioning or POAP can be also used to automatically install and onboard switches without manual configuration. You know that, right? The first login NX-OS prompts for passwords configuration and a basic system setup. You are asked whether to enforce secure password standards and where to run basic system configuration dialog. In the lab environment, this process is taken or often skipped to speed up the development, where just production environments usually complete this fully. Okay. The management interface is configured similar to iOS devices. You enter configuration mode, assign a host name, configure management 0 interface with an IP address, and define a default route within management VIF. Each switch in Fabric has a unique management IP, allowing Nexus Dashboard to reach and manage all devices. Actually, the management VIF is management zero interface that belongs to the management VIF. This VIF is completely isolated from data traffic on Nexus 95 100 platform, right? You're seeing right here is located on the supervisor module where 9300 platform it is integrated into the switch. This separation protects the control plane access from production traffic issue. Now, let's talk about the Nexus Dashboard. Earlier versions of Nexus Dashboard separated the fabric management, multi-site orchestration, and analytics into different switches. In version 4.1, all these functions are integrated into a single platform. This means the fabric control, monitoring, automation, and analytics are all share the data, same data model and interface, making the operations far more cohesive. The Nexus dashboard can be deployed as a physical appliance, right? And or as a virtual machine, depending on the scale requirements. Physical deployment uses a M8 or M6 servers, or the virtual deployment runs on platforms like ESSi or KVM. The sizing of cluster depends on the number of switches and the features being used, such as telemetry and analytics. The dashboard does not use a single cluster IP. Instead, access is done through management IP addresses. Each node has management interfaces for GUI access and system services, and data interfaces for telemetry, inter-node communication, and controller integrations. Management and the data traffic must be kept on separate subnets, and Linux bonding is used for redundancy. If you install the previous version, such as 3.1, 3.2, you could use same subnet, but like 4.1, it must be kept on separate subnet. That's a tip. There are, you know, strict latency requirements between Nexus dashboard nodes and Fabric switches. Low latency is important for telemetry accuracy and cluster health. In this lab, only out-of-band management connectivity is used. Management interfaces handle GUI access, authentication, firmware uploads, and integrations like intersite, where data interfaces support clustering and telemetry. All right, licensing. It's depending on how like the fabric is used. Only if only layer 2 functionality is required, no license is needed. For layer 3, VXLAN analytics and multi-site features, a subscription license is required. Licenses are available in Essentials, Advantage, and Premier tiers, each enabling additional operational capabilities. Okay. All right, let's get our hands on dirty. We'll create a fabric. Fabric creation is largely automated using Nexus Dashboard best practice templates with a few guided input. Nexus Dashboard creates a VXLAN underlying routing and VPC configurations automatically. The pole set It includes adding switches, assigning roles, creating VPC pairs, and recalculating intent. The developing configuration and across the fabric. All right. Logging to dashboard, click manage fabrics, and we want to create a fabric. All right, the fabric is gonna be a new LAN fabric. Click that and next. In here, we want to create a fabric for Nexus. Select the VXLAN. We have many different type of VXLAN, two actually, data center or campus. Okay, we pick data center. A beautiful VXLAN EVPN IBGP EBGP format with Nexus 9000, 3000 switches. For next, we want to pick advanced configuration mode. The difference are right here. All right, advanced mode exposes all available configuration parameters. Give a name, say VXLAN, EVPN, fabric, simple as that. Okay with the location, BGPS now 65001. Let's pick the essential license here and enable this feature for telemetry, and the telemetry collection is through Aruba band. Click next. Here we enter advanced fabric configuration. Choosing advanced modes, we gain access to all fabric level parameters. So these include underlay addressing, multicast settings, MTU, DNS, NTP, syslog, and other system services. All right. So almost all of these can be changed later without rebuilding the fabric. So first good stuff is general parameters. We will find is fabric packing, interface numbering. We want to use unnumbered, underlay subnet IP mask. Go ahead, use 31. Underlay routing protocol, that's OSPF. RR, route refactor, we have 2, and use default NX gateway MAC. Checklist for enable performance monitoring. Click next. Sorry, go back. We have some other things. Okay. All right, don't skip here. Go to replication. Here saved. Okay, replication. We want to use multicast is default. Multicast group is automatically generated. Keep it. All right. Scroll a little bit down, and in here, rendezvous points. Use 2. We have 2 spines. All right. RP stage ASM. You can have a binder. Okay, we fine with any source, right? Underlay RP loopback IP 254. I'm okay with it. No changes here in replication. All right. Click VPC. First, we want to know VPC pair link VLAN range 3600. Keep that. And VPC pair keep alive option is through management. You can use rootback. All right. VPC pair port channel ID is 500. I'm okay with it. Keep that. Now click protocols. Protocols. Be careful routing rootback. Keep it. Underlay. Underlay VTAP 1. Keep that. And underlay routing protocol tag. We're using tag underlay. That's fine. OSPF area ID is 0, 0, 0, 0. I'm okay with that, right? Now we wanted to change something in resources. Resources first to check is underlay routing loopback IP range. I'm okay with the range 10.2.00.22. Underlay VTAP loopback IP range 10.3.00/22. I'm okay because it's just lab. Underlay RP loopback IP range. I'm also okay with the range. Underlay subnet IP range 10.4. I'm okay. Now scroll a little bit down to a place I will let you know is VRF light deployment. Here says menu. I'm okay, but keep going on. You want to say to see VRF light subnet IP range. This range I'm not okay. So we'll change to 172.16.1.0/24. Okay, and use mask 31. Okay, change all that for your resources. Now we can click next. There's a summary page showing, right? Click submit. Once created, the fabric appears in the fabric list. By opening the details, we can monitor health, development status, and the topology, and even before switches are added. All right, just give it some minutes. I'll pause my video right here. All right, now the fabric credits. Let's view the detail. From the top right, you can perform some actions on the entire fabric and manipulate windows. From the tabs, such as overview, uh, you can perform operations such as checking the status within the fabric and setting policies and creating networks. Now let's click this blue action and add switches. Let's give a seed IP. Now we use this as a default device credential. Unchecked preserve configuration is green field. Okay, we'll delete existing configuration and discover. Let check them all. Add a switch. When the status change from in progress to switch added, we want to then close this tab. All right, let's now confirm it down and close. All right, the next task is to set a role. Click the inventory and want to see on my switches and click the spine, and we want to set the role to be spine. Select, click OK. Here, the leaf 4 will be set to be a border role. Okay, click this warning. Now let's confirm leaf 1, 2, 4, 3 are all leaf role. Now let's configure some VPC pairing. Use the VPC pairing feature to automatically deploy VPC configuration according to best practices. So we know we wanted to use VPC pair between leaf 1. So let's select the leaf 1 and action to set a VPC pairing. Is pairing with leaf 2 is true, being recommended, right? And we want to click save. Virtual pair link. I have video about this. You can check it out why we use virtual pair link. Okay. Now just save because we have physical pair link. Let's first talk about instead of using the physical pair links, fabric pairing uses VXLAN tunnels through the spine. That's virtual pair link. This reduces cabling requirements, eliminating distance limitations, and it keeps VPC operational even across racks or rooms, right? That's the benefit. All right, back here, once rows and pairings are complete, recalculate and deploy is triggered. Nexus Dashboard computes all full configuration intent and prepare it for development. So to do that, check they're all in normal, right? And recalculate the port. So the switches manager, the fabric will recalculate to see if there are any configurations that are needed to be deployed after the recalculation. We will review the changes, and if there are no problems, the configuration will be deployed. Now, after adding switches will restart temporarily. The discover status is unreachable, so please wait until it is okay. Then we do a recalculate and deploy. All right, now the discover status is okay. I will do one more recalculate and deploy. You are seeing pending hundreds of lines, and wanted to click if it allows you to view the configuration details side by side. Please just check what settings are being applied, such as features, VPC, interface, etc. So let's click deploy all. The setting will be spread from Nexus Dashboard to each switch. All right, now status show successful. Let's confirm it is case, and then we can close this after. Now in overview, each stats overview, we could take a look, confirm that it is in sync configuration, sync status, and now close this. Next task is to create a new fabric. Let's onboard existing LAN fabric. Okay. We will onboard an external and interfabric connectivity. It's for my WAN router. So in here, we'll say external fabric. Yes, number is 65002. And we want to use a telemetry. License level is default and submit. To view the details, and one thing I want to change is here in the advanced. General parameters, I want to use fabric monitor mode. Save that. We'll create this fabric for, right, it doesn't let me, so I will delete this fabric, create again. Configuration mode, click advanced, auto band. Enable this fabric monitor mode, submit. Now let's add a switch. This one should be my CSR router. So this is going to be LSXE CSR. And add this. Now we're going to add a router to the fabric. We're going to add a router to the fabric I just created. Okay. And click the WAN router. It's an 8000V. Okay. And add it to it. When you add it, close it. Let's confirm we have a router. Name is WAN router. Role is edge router. Okay. Now let's take a look what we have built. Where we build topology, that is fabric. Want to know here. This is our topology. Well, I can double click to see the more detail, right? and we could see the VPC health. Also check topology configuration of the automatically deploy VPC right here. Okay. Well, I want to show you something. Go to management, fabrics, click here and edit the setting. Want to show you how to add switch using POAP. Okay. In Bootstrap, if you want to enable POAP, enable the Bootstrap and enable your DHCP in here. You could take a look the DHCP v4 and add your DHCP scope, start, end default gateway. Okay. Then when you add a switch, you get detect switch with zero touch with some minimum role. We can assign the role, you can assign the data, all that good stuff. Now let's cancel. We want to next step to create interface and to create access interface, VPC interface. Okay. Now we'll focus on creating interfaces that connect the servers to the fabric, both standard access ports and VPC-based interfaces are configured using policies inside of per CLI port. Nexus Dashboard uses interface policies to define how port behave. Instead of configuring each interface manually, policies define speed, MTU, PDU behavior, and port type are then applied consistently across switches. Now, let's double click the fabric, go to connectivity, and find interfaces. Now, in the future, we want to focus on the switch leave 3. So switch equals leave 3. Leave 3 as port 1516. So I'll find these two interfaces. Let's click 1516. Here, the little action, edit configuration. Now, policy here, we want to change to interface access port. Pick that for the first interface, which is 15. Now, BPDU guard is the true. Port type checked, port fast, MTU, default, want to change to default, not jumbo, and speed is auto. Now, we want to do the next port 1/6. Save and deploy. Now we created an access port to connect the server and deploy config. Close this tab. Now let's verify. Ethernet 1/5, 1/6 are becoming access port. Next we will do is to create VPC interface, leave 1 and leave 2. Okay. Click action, create interface. Interface we'll be creating is a virtual port channel VPC, and the pair is leave 1, leave 2 pair. VPC ID is 1, and we want to pick the policy to be access port. Access port host, that's my policy. Now, let's take a look here. First, let's do 1 for 2, okay? We want to enable configure mirroring. The pair 1 member is 1/5. Okay, so the both 1/5 to 10 and 1 server 11. That's the interface. Port channel mode is active. BBDU true. That's fine. And we'll enable port type fast. MTU change to default. Keep going. LACP timer. Let's make it fast. Click save. And now we close that tab. Next is add a port 1/6 to the server 21 in tenant 2. So go back to interface. We can see VPC once created. Now create an interface. VPC 2, and same thing will pick interface VPC access host. Select this. Enable for mirroring each interface E16. Okay, and default. Timer, we want to pick this fast. Save this config save, then we can close. Go back to the fabric. Inventory. Now you will see switch leaf 1 or 2 are having pending configuration. So pick a list 2, guys, and action configuration, deploy only for list 2. Deploy all. Close. Back to the fabric. Connectivity. The interface here, we wanted to filter only any interface contains VPC. You will see the sync status. It will take some time until it becomes in sync. There you go. Now I will pause my video. This will be part 1 for VXLAN EVPN Nexus Dashboard 4.1. So guys, stay tuned. In next video, we'll first create VRF. Stay tuned.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.